Well, guys, I think we can start. We're already here. I said we're starting at 5 o'clock on the dot. All right, so this time we're going to do electrostatic, and it is also important, guys. In the test tomorrow, if I'm not mistaken, it will be 9 marks. But 9 marks are important, and it's also important for grade 11 as well as grade 12. So please, let's see what can we do. This is a good question to practice. It's mostly what you are going to get in the exam. All right, so let's begin with the question now. The question was done in 2023 in Gauteng. Okay, and the question says two small identical spheres A and B are suspended on long string as shown in the diagram below. The spheres carry charges of positive 5 times 10 to the minus 9 coulomb and negative 2 times 10 to the minus 9 coulomb respectively. And then you have the picture there. They say state the principle of conservation of charge. The two spheres are brought into contact and the spheres are unseparated again. Which sphere A or B will gain electrons? Motivate your answer and calculate the net charge of the two spheres. And then the next question I have to move it a little bit down. They say calculate the charge on each sphere after the separation and calculate the number of electrons. So let's start with the question. I hope, as usual, let me ask if right, as usual, I ask the question if you can hear me, so we can continue. Okay, so let's begin with that specific question, my lovely, beautiful children. All right, so here we are. I have the question there already. Then I don't find my pen is here. So let's solve that question. Let's solve that question real fast. The law of conservation or principle of conservation of a charge is always going to be there. So nothing to say, you have to memorize. It says that the net or total charge all right, the total charge in an isolated system remains the same. So the total charge before, during any physical process, I forgot to write there, let's write it down. During any physical process. It means if you bring those two spheres into contact, there's going to be something to happen there. But the total charge before that physical process of A and B touching each other must be the same as the final. So the total amount of charge must stay constant. The charge on A may change, the charge on B may change, but the total amount must stay the same. This leads to a formula which says that the new charge, new is after any physical process we're speaking about. Let me just quickly go here. Yes, amazing guy. Good. So this Q new is equal to the addition of charge 1 or A, for example, plus charge B divided by 2. This one is after the physical process. That is when you use that formula. Physical process could be when the two spheres touch each other, or if I touch one of the spheres. That is a physical process, all right? So what happens is that charge redistributes after that physical process, and they will change. This is how to calculate a new charge. If you, instead of having two spheres, you get 3, then it's QA plus QB plus the step 1 divided by 3. That is the principle of conservation of charge. There's a lot of cars passing by. Now, the next question is the important one. I have to move to this side so I can see it. And the next question asks for what happens when they touch each other or after they touch each other. So let's go to see. The two spheres coming along and they touch each other. So for instance, A and B are touching each other. You need to know that sphere A is a positive charge, or is positively charged. How do I know that? Because they're telling you that. So this one is positively charged. and sphere B is negatively charged. So what is going to happen as they touch each other? Electrons are going to move, they are going to transfer. Electrons are only the particles that are going to transfer, and they always move from the more negative to the more positive. So in other words, electrons move from the negative charge, which is in this case B, to the positive charge. The electrons always move from the more negative to the more positive. That is what happened during the process there, during the touching of the spheres. All right, let's see to the next question, guys. The next question says, calculate the net charge of the two spheres during contact. So we have to calculate the total charge during contact. That is the same as before and after. All right, so net charge. You know what? Let's calculate all of them. Let's say net charge, and let's write it with a net charge before the charge is equal to QA plus QB. And in this formula, you do have to keep the signs. So this one is equal to 5 times 10 to the minus 9 plus minus 2 times 10 to the minus 9. This one is 5 minus 2 is 3 times 10 to the minus 9 coulomb. That is positive 3. That is before they touching. During, let's say here, Q net, during the time that they are touching each other. This one is going to be QA plus QB. It is the same. The QA is still 5 times 10 to the minus 9 plus minus 2 times 10 to the minus 9. All right, so what is the net charge there? It's going to be 3 positive 3 times 10 to the minus 9 coulomb. That is the net charge before the touching and during the touching. This is a net in its line there. Let's see. So I'm waiting to see if you understand that one, guys. If you understand, we're moving on to the next question. Which the next question is calculate the charge on each sphere after they touch. Yes. So now, after they touch, we have to go here to see what is the new charge on each of the spheres, guys. So we go to that formula. I'm going to write the formula again here. Q new is equal to charge A plus charge B. They not always give mark for that formula, but I recommend you to write it. It's given to you. So why will you not write it? Write the formula. So when you substitute here, you get that is QA is positive 5. Also, you make sure you write the symbols here. All right. So this one is 5 times 10 to the minus 9 plus negative 2 times 10 to the minus 9 divided by 2. All right, so do that calculation for me, guys. Want to check the calculator, my calculator. While you're doing it there on that side, it is 5 times 10 to the minus 9 minus, because plus minus is minus, minus 2 times 10 to the minus 9 divided by 2. I get now in scientific notation, you'll have to turn this on to scientific notation. It's 1,5 times 10 to the minus 9. So the new charge is going to be equal to 1,5 times 10 to the minus 9 coulomb. This is for A and B. This one is a positive charge. A and B, both of them will have a charge of positive 1,5 times 10 to the minus 9. Both of them get that charge after they touch it. And note the following here. If we calculate the net charge after, so we continue here and we say net charge after, that one is equal to 1,5 times 10 to the minus 9 plus 1,5 times 10 to the minus 9. This is equal to 3 times 10 to the minus 9 coulomb. You can see that the net electric charge before, during, and after stay constant. That is the principle of conservation of charge we spoke about at the starting of the video. I hope it's clear up until here. We only have to do one more question. I just, as usual, I have to move all this way. Okay? And I want to know if there is any question up until here. Anything that you don't understand before we go to the last one. The last one is the tricky question here, which they ask you in the last one. In the last one, they ask you about calculate the number of electrons, and I think that is the final one. If I'm not mistaken, let me move it. Yes, that's the final one, guys. Calculate the number of electrons that are transferred during the process. Let me just show you. There we go. You can see it there. All right? So now, to calculate the number of electrons, we need to know how much the charge changed during this process. All right, so let me see if you can see properly the board. Cannot see here, it's a little bit tricky sometimes. Okay, so we have, I think here's enough space, we have to calculate the change in charge. And for this one, you may either use A or B. You know what? I'm going to erase the conservation of charge, so I have enough space, guys. Just allow me to erase this one. There we go. And then I'm going to do it there because I want to do it with both of the charges. All right. So you have to calculate the change in charge. If both charges changes, or both spheres, A changes as well as B, because B loses electron, but A gains those electrons. So change in charge of, for instance, let's say for A, or change in charge for B. You can use either one. All right, so for A, that is final charge minus initial charge for A. If you're using B, will be final charge minus initial charge. Guys, you do not have to do both. I am doing both because I want to show you that you can have either one. All right, so final for A, you go to A, which is 1,5. Each of them is the same, positive 1,5 times 10 to the minus 9. The final for B is positive 1,5 times 10 to the minus 9. Minus the initial A was positive 5 times 10 to the minus 9. The initial B was negative 2 times 10 to the minus 9. So we have to always calculate the change in charge if the question asks you to calculate the number of electrons that move during the process. So when you do this one, guys, if you do it, let me just do it for you all real fast. Here is 1,5 times 10 to the minus 9. Check my calculation, guys. Minus 5 times 10 to the times 10 to the minus 9. The answer is negative 3. Here you will get minus 3 times 10 to the minus 9 coulomb. In the next one, you will also get that answer. All right. Did you know the next one? 3,5. Wait. I get 3,5, guys. Sorry. Let's fix it here. 3,5 times 10 to the 9 coulomb. If you do the other calculation, you'll get the same answer. it is 1,5 times 10 to the 9 plus 2 plus, because it's minus multiplied by minus is positive, plus 2 times 10 to the minus 9, you get 1, what happened here? 1,5, 1,5, no 3, 1,5. 1,5 there. What is the, I have a mistake here? Yes, I have a mistake with B. B is not 1,5, it's 2,5. Yes, that is my mistake. It's 2. Oh, this is 1,5 minus 2. Right? Am I getting the same answer, guys? Now I'm confused. I'm a little bit confused. Let me see again. 1,5 times 10 to the minus 9 minus 5 times 10 to the minus 9, 3,5. Now, why am I not getting here? This is 3,5. 3,5 negative 3,5. Now here is 2. Oh, it's a plus. It's a plus. I subtract. Here is a plus. All right. It is 1,5 times 10 to the 9 plus, because minus and minus is plus, and I subtract. Plus 2 times 10 to the minus 9. There we go. It's 3,5. This is 3,5 times 10 to the minus 9 coulomb. There we go. All right. So I hope that is clear. Let me see. Are you with me, guys? Still? So 3,5. One is positive, one is negative, but it's the same value because both of them change at the same time. So the thing is, this one is negative because that one gains electrons. This one is positive because that one loses the electron. All right. So now to calculate the number of electrons and finish with this question, the number of electrons is equal to charge divided by the charge of one electron. The charge of one electron is given to you all. It's given in the exam. So the only thing you have to do is to substitute. This we're referring to the change in charge. Which one are you going to use? Either one. But this final answer of the number of electrons must be positive. Nothing to say. So it must be positive. Therefore, I'm going to use the first one to make it positive. This one is negative 3,5 times 10 to the minus 9 divided by the charge of one electron is 1,6, negative 1,6 times 10 to the minus 19 coulombs. All right, I have the charge, the constants here on this table. Yes, there we go. So the final answer is going to be, and allow me to do that calculation as well, 3,5 times 10, let's see, 3,5 times 10 to the negative 9 divided by 1,6 times 10 to the negative 19, and I get 2,19 times 10 to the 10 electrons. Guys, those are the number of electrons that were transferred during the process. I am done with the question. I just want to know now if there is any question. Any question at all, either about this question or any question. Because this question is done. I think from these last two streams regarding the graph, I think it was quite clear. I rewatched the stream after we finished, and now with this one, this topic is also quite clear. Now the only thing here is you need to know that this, before they touch each other, they were attracting each other because there is positive and negative. After they touch, they will be repelling because both of them will have a positive charge of 1,5 coulomb. 1,5 times 10 to the minus 9 coulomb. I hope it's clear with you all. So I'm just waiting now for answers. I'm waiting for answers or questions, let's say. So from my side, I'm done. Yes, can you still want to ask? You may ask. You may ask. I'm actually waiting for questions. I'm actually waiting for questions. I have here the questions. Oh, I'm really glad. I'm really glad you understand and you understood and right. So I just want to wait a few more minutes, guys. I'm going to wait a few more minutes to see if there is any question. If there is any, if there is not any question, then we can finish. Okay, Owetu, what did you do? It's fine. You can do it in a different way, but give me an idea of what you did. What you did. Remember here? Remember I said you don't have to do both, guys. You only do either one. Either one. I did both to show you that you will get the same answer. Owetu did something different, she said. I just want to know what it's referring to, of how to get in that this number of electrons, I guess he's speaking about. Okay. I'm just waiting for Jan Owetu. She said she did something different, guys. So I just want to know. I just want to know. Maybe she said if it got the same answer, it should be fine. But you know, sometimes you get the correct answer, but not necessarily the questions are correct 100%. Okay. And yes, we did electric circuit yesterday, guys. It was not the best one. I think now I get the idea of the stream. So I'm sure for paper 2, if you people want, it will be much better. And then we can organize, maybe tomorrow we can do a little bit, Saturday, I don't know, it's entirely up to you. It's entirely up to you. So you calculate the number of electrons before they touch and after. Okay, yes, that is also 100% correct. To me, it seems it's more work, but it's the same. What young lady in the chat did was the following. She used this formula. And she calculated the number of electrons before for A and after. So before they touch and after they touch. Then you calculate the number of electrons, the changes in electrons. That is correct. So you have the number of electrons before, number of electrons after, you calculate the change of electron, because the question asked what was the change in electron. How many electrons were transferred during the process? That is the change in electrons. So yes, that is 100% correct. You full marks if you do that. And then guys, I just going to wait if there is any question. Well, guys, if there's no any question, then we can end here. We can finish the stream here. Yes, I'm going to do things at home. I'm going to rest a little bit. Why? Do you have a question, Kanjisile? Okay. So thank you, guys. Thank you for watching the stream. It'll get better eventually. Once more, don't be stingy, man. Give the likes of the video. Thank you. I'll see you next time, guys.